Waves move depending on the constraints on their motion. If you make one particle or enclosed area of a medium vibrate, then this will create waves radiating from that point. You can see this by throwing a stone into a pond. The waves radiate out from the point where the stone hit the water in circles. If you make a line of particles vibrate in sync, then they in turn will make the line of particles in front of them vibrate in sync, and move the wave forward in a straight line. The situation is more complicated at the edge of the line, but that is a discussion for another time. In this way, it can be said that waves travel in straight lines depending on how they were formed. Once a wave is made to travel in a straight line, you cannot change it. That is, unless you change the nature of the medium it is travelling through. If a wave is vibrating up and down and moving forwards, it will travel forwards. If, however, you make the medium thinner, so that the particle has less space to vibrate in, you change the nature of the wave. The energy in the wave is still the same as it was before, but it cannot go into making the particle vibrate as much as it did before. Instead, it transfers more of its energy into making the particles in front of it move. This particle does the same, and so the wave going through a shallower medium goes faster. Its wave speed increases. When the medium becomes deep again, the energy goes back to making the particle vibrate higher, and the wave slows down again. The same is true if a wave starts off by travelling into a deeper area of the medium. It doesn't matter at what speed the wave started, merely the interface between types of medium. If you go from thick to thin, or deep to shallow, the wave speeds up. If you go from thick to shallow, from thin to thick, or shallow to deep, the wave slows down. Of course, it's not just depth of medium that changes the speed of a wave. If the wave were to go from one medium where it could travel quickly to one where it could only travel slowly, then the rules about slowing down waves apply from above. The opposite is true for transition to a faster medium. What matters is the change in speed due to a change in the medium. Speeding up does one thing, slowing down another. But what about changing media at an angle?